you've got DUNE, which stands for Deep Underground Neutrino Experiment. This is called a long baseline neutrino experiment, so LBNE. So what happens is we know there's CP violation in like mesons, B mesons, K mesons, and stuff like this. But now we want to also know about CP violation in neutrinos. So what we do is at Fermilab we basically develop a beam, which will produce a beam of particles that will hit a target and then produce loads of neutrinos, and then the neutrinos will come. I think it's like 2,000 kilometers away. Let me check that. Yeah, 1,300 kilometers away. So underground, and it's there to see all of the neutrinos that come from Fermilab. So the DUNE detector is actually in a mine in South, or will be. It's being constructed at the moment, but it will be in a mine in South Dakota. So much deeper than the LHC, like a mile deep rather than 100 meters deep.
Wow.
And the reason is to shield it, from all the backgrounds, because as many backgrounds as possible, and to keep it as isolated as possible. And then, what we're doing is we're trying to see from the neutrinos that we're kind of sending, which ones actually arrive there, and in what state are they when they arrive. So neutrinos can oscillate, which means they can change flavor from so an electron neutrino can change to a muon neutrino. And that rate should be the same for particles and antiparticles, so neutrinos and antineutrinos. But if it's not the same, then that's another example of CP violation. So this experiment's primary goal is to basically look for CP violation in the neutrino sector. And one of the reasons we're doing this is because the CP violation we've seen so far isn't enough to explain what we've seen in the universe.
Oh, really? So how far off is it?
That's a good question. I don't know. I have to look it up. I think currently they just know it's at least orders of magnitude away from what it needs to be. And they think it's, so there's got to be like a Coleman, they think there's got to be more to it than we understand, So they need to look, so they're looking at whether or not neutrinos have a much larger CP violating effect than what we know already. And then that might explain why there's so much matter.
So one of the questions I have is so you're talking about whether they change when they're firing the neutrinos and then they're detecting them. How do they know that the neutrino they sent is the same neutrino that's hitting the other thing? Do they have because how does that work? Because neutrinos are super small as well, right? So how can they know which one is which, or is it some kind of average they're taking of what's going on?
Yeah, I think it's a good question. The thing is, we're going to be producing loads of one type of neutrino. And so if we see quite a lot of the other type, then we already know that there's some, a difference. And we can estimate the flux of neutrinos that are leaving based on our beamline and the target and stuff. And so we'll be comparing it to what we really see there. And I think that's the way that it's done. Let me just double check that. Yeah, I think that's basically what it says here. So yeah, that's what they're looking for.
Also, how are you producing neutrinos? What? How are you producing neutrinos? What does that? How does that happen?
Yeah. So what we're going to do is I think it produces pions, and then we whack them into a target, but I don't know exactly what the kind of target is and stuff. Let me see. Yeah, it says the Fermilab will smash protons into a fixed target, which will produce pions and kaons. So these are just mesons that are produced kind of quite frequently. So, there's loads of them. There'll be loads of them. And then they'll decay. And as part of their decay, they'll produce neutrinos.
I see. Okay.
There's a good link on this at the Brookhaven website. And then what we'll do, so we're going to be producing mostly muon neutrinos in that way, and then we'll be looking at which ones kind of arrive at DUNE, which is going to be this huge chamber of 40,000 tons of liquid argon underground in this big chamber. And the neutrinos will basically come and interact with the liquid argon, and we'll try and actually measure what type of the flux of neutrinos and what type of neutrino we're seeing, basically at DUNE.
Wow.
Yeah, so there's a lot, and DUNE is the next big thing. Like, it's massive. It's got a lot of money. It's basically America's flagship project in particle physics.
Yeah, when I was there in 2018, they were there was a British girl there, actually. I don't know if she had worked at CERN. I think she did her PhD and then just went straight out there, and everybody at Fermilab was like, yes, this is the thing, neutrinos. And I think they were just getting loads of people in. There's a lot of momentum behind.
yeah. There's a lot, and the UK is big into it now.
Yeah.
It's got more money than the Atlas apart from Atlas and CMS, Hyalumi LHC. This is the biggest project in the UK. So and I think there's a lot of interesting physics here now. Like, people are thinking, because Atlas and CERN are kind of just colliding stuff, let's see what happens. Here they've got really a dedicated measurement to make.
Yeah.
Like, they know what they want to look for, they know exactly kind of what should happen, and they've got the technology to really find stuff out. I mean, the other thing is, it's not just from looking at these neutrinos, it's also going to look at neutrinos coming from space.
Yeah, I think I remember something like that here.
So it can, neutrinos, for example, one of the things that we're kind of really hoping will happen is that there'll be a supernova explosion during the lifetime of DUNE, and then that will create loads of neutrinos that will come from space, and we should see them at DUNE.
Wow.
Yeah, and so that is kind of like one of the, basically just to find out more about the kind of interactions that go on in supernovae and space, and all of this type of stuff. It will be useful to really useful for us to see them, basically.
Yeah.
So that's something that we're working at. What have I missed?
So in terms of, it's the CP violation thing.
Yeah.